says, what is the output of the following C code? Assume that the address of X is 2000 in decimal and an integer requires 4 bytes of memory. So the code is, you are given a function main, int main, inside main in unsigned int x43. That means this is a 2D array named X which has 4 rows, each having 3 columns, and you are given that this 2D array is initialized with the values 1 to 3 in row 1, 4, 5, 6 in row 2, 7, 8, 9 in row 3, and 10, 11, 12 in row 4. And you have to find out what would be the output of this printf statement. And the printf statement says to print the values x plus 3, star of x plus 3, and star of x plus 2 plus 3. Alright, so in a case of a 2D array, what is the most important thing that you need to understand before you start solving the question is how the 2D array is arranged. Alright, so let's draw a quick pictorial diagram or representation of how this array, 2D array X, would be actually arranged. Alright, so there are 4 rows, so I would be representing like this. Let's assume that X is a 1D array in which each element is a pointer to another 1D array which has elements, each having 3 elements. Okay, so since we are given the initial address of X is 2000, so this is 2000. This first value, that means the first value of 1 that is present in the 2D array would have the same address as the starting address of the array. So this would be 2000 and this value would be 1, 2 and 3. Since each integer occupies 4 bytes, therefore the next value 2004 and then the next address would be 2008. So the second value 2 would be present at the address 2004. The third value 3 would be present at 2008. Alright, so this is the first row that I am representing. Okay, now since each integer is occupying 4 bytes, therefore the second row would start at the address 2012. Alright, similarly, if I draw the 1D array corresponding to this row, it would have 3 elements, 4, 5, 6, 7, 8, 9, and this would have next 3 elements that have been specified to you, which are 10, 11 and 12. Alright, so this was 2008. This address would be 2012. Okay, 2012, then plus 4, which is 2016, then plus 4, which is 2020. Okay, now the next address would be 2020 plus 4, which is 2024. Therefore this address would be 2024, then 2028, then 2032 plus 4, adding to 2032 we get 2036. So this is 2036, 2040 and 2042. Alright, so this same thing you can also represent as that X of 0, that means the first element is present at the address 2000 and this element has, or it points to an array of 3 integers 1, 2 and 3, and each of these integers are present at the location 2000, then 2004, then 2008. Alright, and similarly you can write for X equal to X of 1. X of 1 would be starting at 2012, then X of 2 would be starting at 2024. So I'm just writing X of 1, that means the first index would be starting at 2012, then X of 2 would be at 2024 and X of 3 That means the last element which represents the last row would be starting at 2036. So this is another way of visualizing this same 2D array that you would have thought of like this. See, 1, 2, 3, then 4, 5, 6, 7, 8, 9, and 10, 11, 12. Generally, students visualize the 2D array like this, a matrix, and then they assign addresses to each of these values. So another way of doing that same thing is this. All right, so when we have something, a question like this, you can visualize the concept that is specified like I have told you, and then proceed forward. So now what is the first printf statement that is being asked? The first value that is being asked is x plus 3. Now, one more thing that I would like to explain before we get to the answer is that in case of arrays, whenever you add a particular number or a constant value to any array, then the constant that you are adding is not the literal constant value. You always multiply the data type of the element to which you are adding that constant. Okay, so what do I mean here is that in this case x plus 3, x is a 2D array, alright, 2D array, and each element or a single element of a 2D array represents a 1D array. Alright, so by x plus 3, what we actually mean is x plus 3 into size of a single element of this 2D array, size of one element of this array, and this is a 2D array, so a single element of this 2D array is a 1D array. Alright, and the size of a 1D array is 3 elements, each occupying 4 bytes. So 3 into 4, it gives you 12. Alright, the starting address of x is 2000. Then there are 3 elements. You have to add 3. So 3 multiplied by 4 would be the address or would be the size of a single array. So this value would come out to be 12, and now you have to multiply it by 3. Alright, so this is the value that would be the answer to your printf statement of x plus 3. So x plus 3 is 2000 plus 3 into 12, which is 2000 plus 3 into 12 is 36. So this gives you 2036. Alright, now coming to the second printf question or the second part of this printf statement, star of x plus 3. Since we know that x plus 3 is 2036, so basically we are being asked star of 2036. Since 2036 here represents a 1D array, so basically the first element of this 2036 would be the answer to this question. Now in a 2D array, you must remember, in a 2D array, whenever you use double star or double dereference operator, then you get the actual value. But if you use a single star or a single dereference operator, you get the address of the array that is present in that 2D array at that location, address of the element that is present, alright, or address of the array that is present. So in this, at 2036, we have an element which is a 1D array, and the element the address of that element is 2036. So the answer to this would also be 2036. This is quite tricky, but you must always remember that in a 2D array, only when you have double dereference operator. See, if you would have been asked star star 2036, then at 2036, what is the element present? This element is actually present, which is the address of the 1D array that is present at 2036. And what is this address? It is again 2036. So that is why star of 2036 will give you 2036, and again a star of 2036 would give you the element 10. So double dereferencing operator would give you the actual value, whereas in a 2D array, if a single dereference operator is being used, then it will give you the address or the starting address of the 1D array that is present at that location. All right, now coming to the last part of this printf, it asks you x plus 2 plus 3. Now let's see here. X is a 2D array. So 2D array which starts at 2000. Alright. Now adding 2 to it means 2 multiplied by the size of a single element of this array. What is the size of a single element? This is the size of a single element. So this is basically giving you 3 into 12. Alright. So this would give you plus 3. Now what does this expression become? It basically becomes star of 2024. 2024 plus 3. Alright. Now as I said, what is 2024? 2024 is a location, and the element that would be present at 2024 would be the starting address of the 1D array. So this is 2024 again that would be present. So this value is 2024 plus 3. Now 3 means multiply 3 with the size of one element of this array. Now 2024 is this 1D array, and the 1D in this 1D array, each element is of size 4. Alright, initially in the 2D array, each element was a 1D array whose size was 3 into 4, which is 12. But here 2024 is a 1D array where each element is of size 4. So we'll add or we'll multiply it by 4, and 2024 plus 3 4s are 12 would become again 2036. Therefore, in each case, the answer would be 2036. Here also 2036 in the first part. X plus star of x plus 3 also gave us 2036, and the last expression also gave us 2036. So the correct option is A. Alright, so please don't get confused in such questions. That is why I draw the pictorial representation of the 2D array, because it would be useful while explaining it to you. So in case of additions in array, or in case of double dereference operator or the use of single dereference operator, please keep in mind that what is being added to the array, or what is the actual data type of the array that is to which the constant is being added. Here the data type was a 2D array. You can consider it as an int 2D array. So adding 3 to it means adding 3 multiplied by the size of one element of this 2D array. And the first one is, consider the following C function: int fun, int of n, int x equal to 1, comma k. If n is equal to 1, then return x. For k equal to 1, k less than, sorry, it won't be equal to 1, it should be k equal to 1 because it's an assignment in the for loop. So k equal to 1, k less than n plus k, then x is equal to x plus fun of k multiplied by fun of n minus k, and then after the loop return x. The return value of fun of 5 is, alright, so it's a recursive question or a recursive function, and you have to find out what would be the final value returned when fun, this function, is called with the parameter 5. So let's see what happens when fun of 5 is called. Fun of 5, if I write fun, I'm writing the shorthand f for fun. So f of 5 Basically, what does it do? It assigns n equal to 5. Alright, so int x is equal to 1. X is initialized to the value 1. K, we have another variable k. Now if n is equal to 1, no, n is equal to 5. Therefore we'll enter into the for loop for k is equal to 1. K is initialized 1. K is less than n. Yes, 1 is less than 5. So x is equal to x plus fun of k into fun of n minus k. So f of 5, what it will do is x, it will assign to x the initial value of x, which is 1, plus f of, that means fun of k. K is 1 multiplied by f of 5 minus 1, which is 4. Alright, and once we calculate this entire value, this value, there would be another call because the iteration of the for loops have not yet ended. Okay, once we calculate this value, the value of k would be incremented in the for loop. It becomes 2. 2 is less than 5. Therefore, to the existing value of x, currently existing value of x is this 1 plus f of 1 into f of 4. This is the existing value, and now we'll again add the result of f of k. K is 2, so f of 2 multiplied by n minus 2, which is f of 3. Alright, now again we go to the next iteration of the for loop. K is incremented and we add to the current value of x. Current value of x is this entire statement. We add f of k. Fun of k means f of 3 multiplied by f of 5 minus 3, which is 2. Then again k is incremented, which becomes 4. 4 is less than 5, and we add to this value f of, I'm writing here, f of 4, which is f fun of k multiplied by fun of n minus 1. 5 minus 4 is f of 1. Alright, so this is the first expression, and when k is incremented again and it becomes 5, this condition becomes false and we come out of the for loop and we return. Alright, so whatever would be the value returned by this, or whatever would be the value of this expression, that would be the answer to this question. Alright, now in this expression we need to first calculate different values like f of 4, f of 3, f of 2 and f of 1. That means fun of 4, 3, 2 and 1. So let's calculate. F of 4 would run on similar lines. See, when we call f of 4, n would now become 4, x is again 1, we initialize k to 1. Alright, so what would happen? 1 plus f of 1 multiplied by f of 4 minus 1, which is f of 3. Alright, then when k becomes 2, the value would be, the recursive call would be made for fun of 2 multiplied by 4 minus 2, which is again f of 2, plus then the last value in this for loop would be k equal to 3. So this would be f of k, which is f of 3 multiplied by f of 1. Alright, now for f equal to 3, what would be the values? See, we need 3 here also, f of 3. 1 plus f of k, k is 1 multiplied by 3 minus 1. Okay, so in this iteration, this is n minus k, that means 3 minus 1 is 2. Then f of 2 multiplied by f of 1. This is what would be the last statement. Then calculating f of 2 would be 1 plus f of 1 multiplied by f of 1, and finally f of 1 would be, if n is equal to 1, return x. That means we return the value 1 here. Okay, so when this value is returned, we substitute in this value because the function call of f of 2 required f of 1. So this becomes 1 plus 1 into 1, which is 1. Therefore, the value of f of 2 is 2. Alright. In this case, in case of f of 3, what is the value? 1 plus f of 1 is 1, f of 2 is 2. So this is 2 plus f of 2 into f of 1, which is again 2. So this value becomes 5. Alright. So this is f of 2, this is f of 3. Now calculating f of 4. This f of 4 is 1 plus f of 1 is 1, f of 3 is 5, then f of 2 is 2. So 2 into 2 is 4. Then f of 3 is 5. 5 into 1 is 5. So this becomes 15. So the value here is 15. Alright. Now final value we need to compute for f of 5. F of 5 is nothing but 1 plus f of 1 into f of 4. F of 4 is 15. F of 1 is 1. So 15 plus f of 2 into f of 3. So 2 and 3. The values would be 5 into 2, which is 10. Then plus again 10. Then 15, and the sum of these would be 30 plus 20 and 51. 51. So the answer to this question is 51. Alright, so if you are clear with recursive calls, how do they work and how the value returned by the previous recursive calls would be used in computing the actual value that we want, then this question is not at all difficult. Alright, so coming to the next question. Next question says, consider the following code, and in the code you are given that there is a while loop while first is less than equal to last. If a of m is less than s, then first is equal to m plus 1. Else if a of m is equal to s, found is equal to true. Else last is equal to m minus 1 and m is equal to first plus last by 2. Then after the while loop there is an if statement which says if first greater than last, then not present is equal to true. So basically it's searching for an element and returning whether the element is present or not. So the cyclomatic complexity of this code is, alright, so one shortcut for finding cyclomatic complexity is the total number of predicate nodes plus 1. Now what is a predicate node? A predicate node is any node which has an out degree of 2. That means any node at which we are making certain decision would have two different nodes that correspond as the children to the initial predicate node. Okay, so what do I mean here? That cyclomatic complexity can be written as 1 plus number of predicate nodes. Now what is a predicate node? Predicate nodes are any nodes at which a particular decision is made or a condition is checked, and there are at least two emerging nodes from that particular predicate node. So this is a predicate node because at this a condition is checked and a decision was made, say true or false, and based on that decision either of the two paths would have been taken. So a node that has the out degree of at least 2 is a predicate node. So what are the nodes that are predicate nodes here? While loop is a predicate node, if is a predicate node, else if, and this if. Now see why this particular else is not a predicate node, because when we construct the node for a while loop in the control flow graph, then either we would check this condition first is less than equal to last, and based on this condition we would either enter into this inner while loop or we would directly come to this condition of if. Okay, now this if it is true, we would execute the statement not present, else we'll directly jump out of this if and come to the last statement. Suppose this is the last statement or the next statement after not present. Statement after this particular statement which I am denoting by star. All right, now if we checked the while condition, if it was true, this is the while condition, this was the if condition when the while was false. All right, if it is true, we again check the if condition. So this is the if condition again. At this again there would be a decision. If this condition is true, then we would execute this statement, otherwise we would jump to an else if statement. Okay, now this is an else if, and if this condition inside this brackets are true, then we would execute this particular node or this particular statement of found equal to true. If it is false, we would jump to the else part. In this else part, which is represented by this node, there is no decision being made. If we have not entered into any of the previous if statements, we would definitely enter here. Alright, and therefore after executing this statement last is equal to m minus 1, we would directly jump to this node which I'm denoting by hash. So this is denoted by hash. This would come here, this would come here, and basically I have drawn the flow graph for you. So, and this would be control flow graph. So what we are doing at while, we are making a decision. Again, when we enter while, this is the first if at which we are making a decision. If this if is not true, then we go to the else if node at which we are making a decision. And again, if this else if is not true, we directly execute this else node and come to this statement m equal to first plus last by 2. And after all of this has been executed, see, if while was not true, then we would, from here we would directly jump to the while loop. Okay, so after this particular condition would have been executed, we would again jump back to the while loop. That would also be a part of the control graph. So what I meant to say, that there are 4 predicate nodes and else is not a predicate node. Therefore the answer for this question would be 1 plus 4, and that is 5. All right, you can also complete this control flow graph and find out that what are the number of nodes, what is the number of edges, and then find out the cyclomatic complexity. All right, so if you do that way, you would find out that the total number of edges would come out to be around 13, the total number of nodes would come out to be around 10, and applying the formula of e minus n plus 2, you would again 13 minus 10 plus 2 would give you 5 again, which is the answer. All right, so you can do it by any of the 2 ways, but I find that for exams like GATE and UGC NET, you need quick ways in which you can solve the question in as less time as possible. Therefore, counting the number of predicate nodes is one of those ways. That's all for today's lecture. Thank you for staying together till the end. If you like this video, please share it with your friends and let us know in the comment section below how did you find this video. Subscribe to our channel and press the bell icon to get to the notifications of the videos that we upload in future. Thank you. Stay tuned. Good luck.